Welcome back to the next session of electrostatic potential. Friends, in this topic, we are studying the potential energy in an external electric field. If you just recall the previous class or previous session, there we discussed the potential energy, a system of charges in absence of electric field. Now today we are discussing in presence of electric field. So what is the difference between electric field in presence of electric field and in absence of electric field? In the last session itself I explained, if I consider empty space which is free from the charges, obviously it is free from electric field as also potential. Now somewhere in this session, somewhere the source charge is kept. That source charge is producing the electric field as well as the electric potential, and that electric field is now treated as the external electric field as well as the external potential. In this case, and that electric field is passing through this board, hence the entire board itself is considered as external electric field. If you have not understood this concept, let me clarify in another manner. Now if I consider the entire board as space free from electric field, no charge, nothing is there, what I will do, in this corner I will keep a source charge capital Q which will producing this electric field. As I said in the first chapter, source charge is a charge which produces the electric field. Hence the charge Q is producing the electric field, and that electric field passing through this entire board, and which is not uniform. Hence we have different potential at different points and different electric field at different points with respect to the source charge. As a result, the entire board is considered as an external electric field. Understood? Now afterwards we start with our again same concept, that is case A, case B, case then. Case A says potential energy of a single charge. This take us to the chemistry study also. Somewhere related to the chemistry too. Very important, pay the attention, and very important as our modern physics or atomic physics is concerned. Now friends, already we know that if there is a charge, if there is an electric field, and to that, with respect to that electric field, if I bring another charge, say UPC, from infinity to the point against to the electric field, what happens? Work is done. As a result, already the charge is there, that is producing the electric field. The entire board itself is consisting of electric field. Now let me consider a point, say A. At this point A, potential is V, right? So if I bring the charge UPC from infinity to the point, say A, what happens? Work is done, and that work done is given by U is equal to VQ. Very simple, over. Potential energy of a single charge. Consider a point A in an external electric field having the potential V. So stop. Bring a charge UPC or bring a UPC or a charge from infinity to the point A. Potential energy stored in charge Q due to the potential V, and that is given by U equal to VQ. Friends, afterwards, if I go with one more important concept related to this concept only, let us see here. If charge Q is say equal to plus 1 coulomb, I can say UPC, or better say UPC. Instead of taking V, if I take V is equal to 1 volt, or say VA difference VB is equal to 1 volt. If the potential difference is 1 volt, if I consider 2 points, better say. If I consider 2 points, then the potential difference between those 2 points, say 1 volt, and if I bring the charge Q, so now point A is here, point B is here, having the potential VB, and the difference between these two is 1 volt. 1 volt difference is there. Then if I bring the charge Q from A to B, or accelerated the charge Q from A to B, what happens? Energy work is done. How much work is done? Look at this now. If a charge Q is accelerated at the potential difference of dV, then work done is, or potential U is equal to Q into dV. Now in the place of Q, UPC, if I take a charge electron, in the place of Q, if I take electron, or I can say if an electron is accelerated, at the potential difference of 1 volt, then potential energy is given by, what is U is equal to, Q is how much, E, potential is how much, EV, or else you can write here the charge of the electron is 1.6 into 10 raised to minus 19 coulomb, and the potential difference is how much, 1 volt, that is equal to 1.6 into 10 raised to minus 19. I am multiplying coulomb with a volt, hence it becomes a joule. So then means I can write here 1 electron volt. Please note down here 1 small e capital B. 1 electron volt is equal to 1.6 into 10 raised to minus 19 joule. I think you would have seen this word or value in first PUC in chemistry or else in physics. What this says, 1 electron volt is equal to 1.6 into 10 raised to minus 19 joules. Friends, if you go to the atomic level, the value or the energy gap between the two energy levels not measured in terms of joules, because joules is a very high quantity or high value compared to the electron volt. Hence we convert that joule into electron volt. At that time, the conversion factor, the relation between 1 electron volt and the joule is 1 electron volt is equal to 1.6 into 10 raised to minus 19 joules. So that in the examination, chemistry or else in the modern physics, atoms and nuclei, if they may ask, calculate the energy gap between the two orbits in terms of joules or in terms of electron volt. They may give in terms of joules and ask to calculate in terms of electron volt, or they may give in terms of electron volt, ask them to convert into joules. So we must know this relation. 1 electron volt is equal to 1.6 into 10 raised to minus 19 joules. Afterwards, if you go to the one more system called as system of two charges, right? So what I have to write here, this is very, very important. Now this is case B, potential energy, a system of two charges. Friends, to understand this concept, we must know certain things. Very, very important. Listen carefully. Again, the entire board itself is acting as an external electric field. So in this field, I have to consider, very, very important, look at this, I have to consider two important points because two charges are there. 2 points I have to consider, say point A and point B. What I will do, I will consider 2 points, point A, point B, and the distance between them is, say now, R, just R. Afterwards, what I have to do, I have to bring the charge Q1 from infinity to the point against to the electric field. So if I bring the charge Q1, already at the point A, potential is V1. At the point B, the potential is V2 due to the external electric field. Suppose if I bring the charge Q1 from infinity to the point A, what happens? Energy stored in the charge Q1 is given by, let me write, bring the charge Q1 from infinity to the point A, to the point A. What happened? Work is done. Work is done. That is, that I have to write here. What is that? U1 is equal to, simple, V1 into Q1. That's it. Over. That's it. No problem. Afterwards, here comes very important point. So when I bring the charge Q2 again from infinity to the point B, here is very important. Listen carefully. Already at the point B, one potential is there, one electric field is there. Suppose if I bring the charge Q2 from infinity to the point B, energy is stored in charge Q2 due to V2 is V2 Q2. That's it. V1 Q1, V2 Q2. Over. At the same time, friends, look at this. Already we place charge Q1. Once we place charge Q1, now at the point P, how many potentials are there? Two potentials are there. One potential is due to this external electric field, that is V2. And another potential is due to the charge Q1. Hence, at the point B, there are how many potentials? Two potentials are there. So now, what I have to do is, I have to bring the charge from infinity, bring the charge Q2 from infinity to the point B. What happened again? Simple sentence. Work is done. So the potential at a point P is given by U2 is equal to, what I have to write here? First one is V2 Q2. First question. But if I bring potential due to potential energy stored in Q2 due to V2 is V2 Q2, and potential energy stored due to Q1 because it is also opposing, and we are bringing against to this electric field produced by the Q1, and that is given by 1 by 4 pi epsilon naught into Q1 Q2 divided by R. That's it. Distance R. Afterwards, merge these two. So if I calculate, therefore, total potential energy due to a system of two charges, in an external electric field is U is equal to U1 plus U2. What is U? V1 Q1. What is V2? V2 Q2 plus 1 by 4 pi epsilon naught into Q1 Q2 divided by R. So this is the potential energy, a system of two charges in an external electric field. So now it's not complicated, I say, but a little bit confusing. So if you see the video again and again, you'll come to know.